Hi, in this video, I'm going to explain the relation evaluate. This is the really fun part of the assignment, and you do need to complete the definition of lookup before proceeding, since lookup is a helper function, or rather a helper relation, of evaluate. So to explain evaluate, I'll start by explaining this eval right here. So eval is an interpreter. And you wrote an interpreter in assignment 1. An interpreter evaluates code in some language and returns the output. And just like in assignment 1, our interpreter takes two arguments, an environment and the expression that we want to evaluate. And the interpreter returns the value of the expression. In our case, our programming language is very different from the language from assignment 1. We don't have pattern matching, all of our functions take a single parameter, and we use the data type term everywhere. This makes our code a little bit clunky, but is necessary because the logic programming system we built only knows how to work with terms. So the most important thing to understand is that interpreters are functions, which means that we can write the relational form of eval, which is called evaluate. And evaluate is also known as a relational interpreter. This evaluate is a relation of three arguments: the environment, the expression, and the output value of the expression. We won't talk about the implementation of eval and evaluate. You're certainly welcome to take a look, and you should be able to understand the definition of eval here. The definition of the definition of evaluate follows that of eval the same way that appendo followed the definition of append. What you should understand is that just like in our previous examples from part 2, any combination of these three arguments can be logic variables. So we can ask questions like, what does the expression cons 3,2 evaluate to? And let's look at the answer. So let's just get both of these in our environment here. And the answer is t-pair 3,2. And this is actually our only answer. So notice that here we need the t-quote here to show that the 3 and the 2 here are literal values that don't need further evaluation. So this isn't really that interesting of a question because we can answer this question using good old eval. So here's a little bit more interesting question. With what environment will the variable x evaluate to the integer 3? So let's look at this, and here's one answer, one possible environment. We have x bound to integer 3 here in this environment. And by the way, there's an infinite number of answers here since we're using an association list to represent environments. So the environment binding of x to 3 could be in the first position, it could be in the second position of the association list, third position of the association list, etc. One of your tasks is to ask the question, what expression will evaluate to the number 42? And I hope you see that working with evaluate is not that different from working with other relations, just a little more interesting. Oh, and one way to check your answer is to evaluate your expression, maybe using eval, and see if it evaluates to the integer 42. And finally, in the program synthesis portion of the assignment, we give a little bit more structure to the expression in our query here. In this expression, we have a function application. We're applying this function to this argument, and the argument here is a logic variable, and the body of the function is also a logic variable. And what we really care about is the body here, and this is our body. And having this quote here is completely fine. You should actually have the quote here, just so that the interpreter knows not to try to further evaluate this value.